So in this video, we're going to explain a little bit about the unit circle and talk about how to get coordinates, how to get angles off of the unit circle. So first of all, why do we call it a unit circle? Because the length of the radius on the circle is 1 unit, 1. So based on that, you can, and I always recommend, that you go through and you fill in the coordinates at the quadrantal angles. So if we know, for example, our center is at the origin 0, 0, the coordinate furthest to the right of the center is at 1, 0. That means the coordinates here at the top would be 0, 1. Farthest left, negative 1, 0. The bottom, 0, negative 1. Then I would go in and I would fill in the quadrantal angles, right, in degree measures first. So starting from 0, going in a counterclockwise rotation, up top, that would of course be my 90-degree angle, 180 degrees, furthest left, 270 at the bottom, back at 360. Okay. Now, if you're going to go through and find some other angle measures, the way I can approach it is various ways, obviously, but I think one of the easier ways probably to maybe explain it and process it is, if I know the middle angles first, I can fill those in and kind of go around the circle that way and use the angles that are the quadrantals that I already have. So for example, this angle here, directly in the middle of 0 and 90 degrees, is basically slicing 90 degrees in half, so that's 45 degrees. So we should all be able to identify that easily, right? That's a 45-degree angle. So from 0 to halfway is 45 degrees. Another 45 degrees is at 90. That means another 45 degrees should put you at 135. And then another 45 puts you at 180. Another 45 puts you at 225. Another 45 puts you at 270. Another 45 puts you here at 315. And then another 45 puts you here back at 360. And so just like that, you have all your corner angles as well as your middle angles filled in. Now what we're going to look at is the other angles and degree measures we can fill in. So going back here to quadrant 1, looking at this angle measure here that I'm tracing over, if I compare it to 90 degrees, right, which is the right angle here, I can see that this is clearly a third of that, right? That's a chunk of the 90. That's a third of it. So this angle here would be 1/3 of 90 degrees, which means it would be a 30-degree angle. Okay. Going a little higher, this angle measure here is a little bit bigger, but also it looks like this would pair 2/3 of a chunk of 90 degrees, right? So if that's 2/3 of it, that means it's 60. Okay, so like that, now you know the angles in quadrant 1. So if I kind of look at it from that perspective, okay, and I know this is 3, this is 1/3 of 90, this is 2/3 of 90, and then this is 90, 3/3. Coming over here, this would be another third, so this would be 4/3, so another, if you will, 30 degrees. If you kind of look at a pattern, you kind of keep adding 30 degrees, right? And you get 90, and then you add another 30. That will put you right here at 120. You add another, you get 150. Keep adding 30, get 180. Keep adding 30, see we keep adding that third. This is 210. Then another third here, 240. Then another third, 270. Come over here, another 300. And then a final third, 330 to complete, back at 360. Okay, so that's all of your degree measures in. Now you want to go in and start listing your radian measures. So here's how the radian measures work out. If I kind of look at the idea of what I did for the degrees, I'm going to do the exact same thing for the radian measures, okay? So here's what I know. I know that half of 90 degrees was 45 degrees. So I know that in terms of radian measures, before I even go there, I should probably do this first. So starting from 0 radians, right? Wrapping around the full arc length of this circle or circumference is 2 pi. Half of that is pi. A quarter of it is pi over 2, half of pi. 1, 2, 3/4 of it is 3 pi over 2. Okay, so those are the quadrantal angles. Now, going back, we said that half of 90 was 45. So I can ask the same premise. What's half of pi over 2? Since pi over 2 radians is equivalent to 90 degrees. Well, that would be pi over 4. So 1/4 of pi is equivalent to 45 degrees, 1/4 of pi. Now, if I use that, now look at how I use that. 1/4 of pi, 2/4 of pi is at 90. That means that at 135 in the middle, this would be 3/4 of pi. Then this is 4/4 of pi, right? 1, 2, 3, 4/4. Add another fourth here at 225. Now you have 5/4. Another fourth is 6/4, or 3 pi over 2, which we already filled in. Another fourth, that would make this 7 pi over 4, and then another fourth would be 8 pi over 4, or 2 pi. So now you got all your quadrantals filled in. Now, in terms of this angle at 30 degrees, we determined that that was 1/3 of 90. So what's 1/3 of pi over 2? Well, 1/3 of pi over 2 is pi over 6. So that means at 30 degrees, your radian measures pi over 6, 1/6 of pi. So if we count this out around the circle now in terms of a 6 of pi, this is pi right here clearly. So I'm going 1/6 chunks, right? So if I say 1/6 is here, another 30 or another 1/6 would be here. That's 2/6. 2/6 pi, remember, is pi over 3. I'm trying not to make this look too messy, but I'll say them out loud so you can hear it. 1 pi over 6, 2 pi over 6 at 60, 3 pi over 6 at 90, 4 pi over 6 at 120. But I can reduce that to 2 pi over 3. It's at 120. Then this would be 5 pi over 6. Still counting in sixes. 6 pi over 6. Here at 210, 7 pi over 6. At 240 is 8 pi over 6. That's 4 pi over 3. Nine pi over 6 here at 270, which is still 3 pi over 2. 10 pi over 6. 10 pi over 6 is really 5 pi over 3 at 300. And then here at 330, I'm going to put it in the middle-ish. 11 pi over 6 at 330. And then 12 pi over 6 is back at 2 pi. So that's all your radian measures or your arc lengths around the circle that complement the degree measures. So the last piece that I want to focus on and discuss is how to get the coordinates at these angles that we just found around the unit circle. Now, for quadrant 1, if I would start there, there's 3 coordinates that you could start from in terms of how to get the rest. And so if you list out your coordinates first, I will list them out for you at 30, 45, and 60, respectfully. So here's what they are. So at 30, you have root 3 over 2, comma 1/2. At 45, you have root 2 over 2, root 2 over 2. And then at 60, you have the reciprocal, basically. Not necessarily the reciprocal, but I guess you just switch the coordinates. Just let's say switch is a better word. Switch the coordinates and you have 1/2 root 3 over 2. Okay? Now, if you wonder, where did those coordinates come from? I always like to explain it through the lens of special right triangles. There are 2 that you would have studied in geometry, the 45, 45, 90, and the 30, 60, 90 right triangles. They're special because their side lengths are specific in terms of their values and what they produce. So if you kind of study your right triangles, your special right triangles, you can then determine and figure out from those and the sides labeled on those special right triangles, you can then determine what the sine and what the cosine is of these 3 angles in quadrant 1. That will explain how you get these 3 coordinates. To get the rest of the coordinates along the unit circle, you want to also, from geometry, use the idea, I like to explain to students, of symmetry. Meaning, if you take these 3 coordinates in quadrant 1 and reflect them across the y-axis over into quadrant 2, you'll get the same coordinates, but all of your y-coordinates will be negative since all your x-coordinates will be negative because you're on the left side of your 0. So that's why, kind of like this -1, 0 coordinate right here. If you want the coordinates in quadrant 3, down here, take all 3 of your coordinates in quadrant 1, reflect them through the origin into quadrant 3, where your x and your y coordinates will both be negative because everything's negative in quadrant 3. If you want your coordinates in quadrant 4, down here in the lower right corner, take your 3 coordinates again in quadrant 1 and reflect them across the x-axis, which will keep the x positive but will make the y coordinate negative. But the coordinate values will be the same. Okay? And that is essentially how you can fill in the remaining coordinates of your unit circle. So you should practice with this. Take a blank circle and kind of go through and fill in all the angles in degrees, fill in all the angles in radians, and then try to fill in all the coordinates around the unit circle. By the way, just so you know and verify these 2 coordinates, if you used the Pythagorean theorem, you will get a radius of 1 after squaring your x-coordinate and your y-coordinate, adding them together, and then finding the square root of that result. You'll see that the result of that would be 1, which proves why these are the coordinates on a unit circle, because you do get a radius of 1, and you should.